Next topic is intersection of line and sphere. So what are the possibilities? That is, the line intersect the sphere in 2 points, or the line intersect the sphere in only one point. In the case of the line intersect the sphere in only one point, then we say line touches to the sphere, or we say the line is tangent to the sphere. If the line touches the sphere in only one point, then we say the line is tangent to the sphere. And if the line intersects the sphere in 2 points, then what happens? We have the distance between these 2 points A and B by using the coordinate of the point P, B, A and B, and by using distance formula. So there are two types question. Find the length of intercept made by the line with the sphere. Means this line intersect this sphere in 2 points, and that's why we have to find the coordinate of that 2 points, and then length of intercept made by the line, means the distance between A and B. That is the length of the intercept made by the line with the sphere. And another type of problem are of this type. Prove that the straight line, this is again the same type straight line like this, touches the sphere. Means you have to show the line intersect the sphere in only one point. Okay. Also find the point of contact. That is that point of intersection of line and sphere. In this case, we have 2 points of intersection of line and sphere. But in this case, we have only 1 point of intersection of line and sphere. So now we have to solve these type examples. So first the example of this type, that is the find the length of the intercept made by the line. So the problem of that type, find the length of the intercept. Yes, this is the problem. Find the coordinates, find the length of, okay. So we'll see the problems of the first type, that the line intersects the sphere. So we'll solve that type problem. Find the length of the intercept made by the line with the sphere. Yes, find the coordinate of points where the line, this line intersects the sphere. So we'll see the problems of this type. So the problem of this type, find the coordinate of points where the line, this x plus 3 by 4, y plus 4 by 3, z minus 8 y minus 5, intersect the sphere x square plus y square plus z square plus 2x minus 10y minus 23 is equal to 0. So this line intersect the sphere in 2 points. Okay. And we have to find the coordinate of that 2 points. So another form of this question is what? Find the length of the intercept made by this line with the sphere this. That is, we have to find the point of contact of these two, that is the line and sphere. We have 2 point of contact, 2 point of intersection of line and sphere. And then by distance formula, we can find the length of the intercept made by the line with the sphere. So the procedure of this problem, answer of this problem. So the equation of line, suppose it is equal to r, say r or lambda, then x is equal to compare this, x minus 7 by 2 is equal to r, gives x is equal to 2r plus 7. Y minus 6 by 1 is equal to r, gives y is equal to r plus 6, and z plus 5 minus 1 is equal to r, gives z is equal to minus r plus minus 5 minus r. This minus 1 shift to this, then minus 1 into r is minus r, and this plus 5 becomes minus 5. and the coordinate of general point on the line. Now the coordinate of any point on this line are of this form: 7 plus 2r, 6 plus r, and minus 5 minus r. If this point lies on the sphere, we have. So if this point, we have to find the point of contact of line and sphere. That is, we have to find the coordinate of the point which lies on the line as well as sphere. And that's why this is the point on the line. Now if this point lies on the sphere, then what we have? This point satisfies the equation of sphere. That is, substitute x as 7 plus 2r, y as 6 plus r, and z as minus r minus 5 or minus 5 minus r in the equation of sphere. We have, what we have? That the equation of sphere is this: x square plus y square plus z square, 7 plus 2r bracket square plus 6 plus r bracket square, plus minus z means minus 5 minus r bracket square, minus uh, 12 into, this is the minus 12 into minus 2 into x, that is minus 2 into 7 plus 2r, this is minus 2x, plus 3 into plus 3 into 6 plus r. I think the question is different. Question number 1. So this is the question: find the coordinate of the point where the line intersect the sphere. This is the question. X minus 7 by x minus 7 Yes, this is the problem. Find the length of the intercept made by the line. So this is the answer of this question. Find the length of the intercept made by the line: x minus 7 by 2, y minus 6 by 1, z plus 5 minus 1 with the sphere. What is the equation of sphere? X square plus y square plus z square minus 2x plus 3y minus 5z minus 31 is equal to 0. So write this problem, and the answer of this problem is this. That is, the equation of line is this. Then substitute the value of x, y, z as a 7 plus 2r, 6 plus r, minus 5 minus r in the equation of sphere. We have this. So minus 2x plus 3y minus 5z minus 31 is equal to 0. This is the equation of sphere. So write this problem, that find the length of the intercept made by the line: x minus 7 by 2, y minus 6 by 1, z plus 5y minus 1 with the sphere: x square plus y square plus z square minus 2x plus 3y minus 5z minus 31 is equal to 0. So if the point lies on the sphere, then we have this. And then find the square of this bracket as 49 plus 7 into 2, 7 into 2, 40, 40, its double is 28, right here 28 r, then plus 4r square, here write 28 r, then 6 plus r square is what? 36 plus 12 r plus r square, then square of this bracket, minus 5 square is plus 25, then multiplication of these two is what? Minus minus become plus 5r, its double is plus 10r, not minus 10r, this is plus 10r. The multiplication of these two is what? The square of x plus y bracket square and minus x minus y bracket square, both are same. So actually this is the square of x 5 plus r. This is plus 10r right here, plus 10r and plus r square. Minus 40 minus 4r minus plus 80 plus 3r minus plus 25 plus 5r minus 31 is equal to 0. And then simplify this. We have the equation 6r square plus 54r, addition and subtraction of r terms, then 1 plus 108 is equal to 0. Then dividing by 6 throughout, so 6 r square, 6 9s are 54, so 9r, and 6 1s are 6 and 6 8s are, so 18. If you divide 108 by 6, then we have 18 answer is equal to 0. And then factorize this. So r plus 6, r plus 3 is the factorizations, because 6 and 3 addition is 9 and 6 and 3 multiplication is 18. So we have r is minus 6, r is minus 3. So we have the two different values of r. So substitute the first value as minus 6. We have the point of contact as substitute r as minus 6. So what do we have? We have 7 minus 12, or minus 12 plus 7, the first value, minus 12 plus 7, comma, then substitute r as minus 6, so 6 minus 6, then comma, then substitute in formula Z is minus 5 minus r, so minus 5 plus 6, minus plus 6 becomes plus 6, so minus 5 plus 6, plus 3 plus 6. So write the value of first, write the value of this r as minus 6. So we have this minus 12 at this place, minus 6 at this place, plus 6. So we have the point of contact as minus 5, 0, and this is the wrong. This is minus, it is not plus 3, it is plus 6, plus 6. So plus 6 and minus 5 becomes 1, right here 1. It is wrong, the minus 2 is wrong answer, right here 1, minus 5, 0, 1. And B is what? Substitute r as minus 3, r as minus 3 in this formula. So minus 6 plus 7 means 1, yes 1, and then minus 3 plus 6 is 3, the second coordinate, and then minus plus 3 minus 5 become minus 2. So this point is correct. Correction is here at minus 5, 0, 1. Okay, and then the length of the intercept is what? These are the point of intersection of line and sphere. That is, the line cuts the sphere in 2 points, intersect the sphere in 2 points, and then length of the intercept is what? AB is equal to root the distance between these two. So 1 minus plus 5 bracket square, then 3 minus 0 bracket square, 3 minus 0 bracket square, and then minus 2, and here is plus 1. So minus 2 minus 1, right here minus 2 minus 1. Okay, and then minus 2 minus 1, right, minus 2 minus 1 at this place. And then we have the answer. Its square is 36, its square is 9, and this is actually minus 3, but its square is again plus 9. So answer is correct. Root 54 answer is correct, but the correction is at this place, right here 1. So we have the root 54 as AB, distance AB, and that is 3 root 6 is the final answer. That is the length of the intercept made by the line, length of the intercept made by the line with the sphere. Find the length of the intercept made by the line with the sphere, made by the line with the sphere, this sphere. Okay, so this is the answer of this question, this answer. So if we have the values of r, both the values of r equal, then we have only one point of contact, or we have only one point of intersection of line and sphere. In that case, we say the line is tangent to the sphere. So when we say the procedure of showing the line is tangent to the sphere, or the line, show that the line touches the sphere, both the problem, answer of that problem is same like this problem, but only the change is what? So only the change at this place, that is, we have the values of r, both the values of r are equal. The values of r, small r, both the values of r are equal. Then we say the point of contact of line and sphere is only one, and in that case we say the line is tangent to the sphere. So we will see that the problem of that type. This is the problem of that type. Example number 3. Here is the example number 3. Prove that the straight line x plus 1 by 4 is equal to y minus 2 by 1 is equal to z minus 2 by 1 touches to the sphere or tangent to the sphere. Wording are different, but the meaning is same. That prove that the line touches the sphere or tangent to the sphere. and the equation of sphere is x square plus y square plus z square is equal to 9. Also find the point of contact. So in this case, the equation of sphere is in the general form. In this case, the equation of sphere is in the standard form. So the procedure of the answer of the problem is same. So we can solve the problem. The equation of line, say it is equal to r, say, and then x is equal to what? X plus 1 by 4 is equal to r gives x is equal to 4r minus 1. Y minus 2 by 1 is equal to r gives y is equal to r plus 2, and z minus 2 divided by 1 is equal to r gives z is equal to r plus 2. And therefore, the coordinate of general point on the line, any point on this line has the coordinate of this type, 4r minus 1 or minus 1 plus 4r, then r plus 2 or 2 plus r, and then r plus 2 or 2 plus r. So any point, coordinate of any point on the line or general point on the line are these, minus 1 plus 4r, 2 plus r, 2 plus r. And we have to find the point of intersection of line and sphere. So if this point lie, which lies on the line, if this point lies on the line, lies on the sphere, then what happens? If this point lies on the sphere, we have what we have. This coordinate of point satisfies the equation of sphere. So what is the equation of sphere? This is the equation of sphere: x square plus y square plus z square is equal to 9. So substitute x as 4r minus 1, so 4r minus 1 square, y as 2 plus r or r plus 2 bracket square plus r plus 2 bracket square is equal to 9. So if this point lies on the sphere, then we have this, that these coordinates satisfies the equation of sphere. And then we have, after simplification, the square of this is what? 16r square minus 8r plus 1, and then r plus 2 square is this, and r plus 2 square is this. So 8r and this 4 plus 4 is 8r, minus 8r becomes 0, and so 18r square is equal to 0. Again, the constant coefficient 4 plus 1 are 9, and if you shift 9 to RHS, then 9 minus 9 is 0. So r square is equal to 0. Therefore, r is what? Values of r are 0 and 0. Both the values are same. Hence, the given line touches the sphere. Why? Because both the roots of the this quadratic equation, or both the root of the quadratic equation, this quadratic equation in R are equal, and therefore the line, the intersection of the line and sphere is only one point, and hence the given line touches the sphere, or given line is tangent to the sphere. And now I have to find the point of contact. So substitute r is equal to 0 in this coordinate of the point, general point on the line. What do we have? The point of contact is, substitute r as 0. So what do we have? Minus 1, 2, 2, minus 1, 2, 2 as a point of intersection. So we will see the another problems of the same type. We will see another problems of the same type. So prove that the straight line x plus 7 by 4, y minus 6 by minus 5, z plus 4 by 5 touches the sphere x square plus y square plus z square minus 4x minus 6y plus 2z minus 19 is equal to 0. Also find the point of contact. So again, we have to show this line is tangent to this sphere. So the procedure is same. The problem is of the type that find the length of the intercept, or find the coordinate where the line touches, intersect the sphere, or show that the line is tangent to the sphere. So all these problems are of the same type. The procedure of solution is same for all these type problems. So the procedure is what? The given equation of line is this. Say it is equal to r. Say, then what we have? X is equal to minus 4r minus 7, y is equal to minus 5r plus 6, and z we compare this to We have Z is 5r minus 4. Then the coordinate of general point or any point on the line are what? This 4, right in round bracket, 4r minus 7, comma, minus 5r plus 6, comma, 5r minus 4. If this point lies on the sphere, we have. So we have to find the point of intersection of line and sphere. So if this point which lies on the line also lies on the sphere, then what we have? We have the this point satisfies the equation of sphere. So substitute in the equation of sphere the value of x as 4r minus 7, value of y as minus 5r plus 6, and the value of z as 5r minus 4. We have this. So if this point lies on the sphere, we have this. That is, this point satisfies the equation of sphere. Then square of this bracket is this. Square of this bracket, then square of this bracket are these three terms, then multiply by minus 4, multiply by minus 6, multiply by 2, minus 19 is equal to 0. And the simplification of the terms is what? If you add the terms of r square, then we have 66 r square. Then the addition of all r terms is minus 132 r, and the constant term is plus 66 is equal to 0. Then dividing by 66 throughout 66. So we have r square minus 2r plus 1 is equal to 0. And then factorize this equation. Directly we have this r square minus 2r plus 1 as r minus 1 bracket square, and therefore r is 1 and 1. Or we can solve, factorize this middle term, that is minus 2r factorized by minus r becomes minus 2r, and then take r as common from this 2, then r minus 1, then they take minus sign common, so we have r minus 1 in bracket, take r minus 1 as a common, so we have r minus 1, and therefore r, the value of r what? 1 and 1. So we have the both the values of r are equal. So the quadratic equation in r means this equation has two equal roots, and therefore the line and sphere have only one point in common, or we say the line touches line intersect the sphere in only one point. If we have the two different values of r, then the line intersect the sphere in two different points. That is situation like this. If we have the two values of r, then situation is like this, that is the line intersect the sphere in 2 points, that is at the point a and at the point b. But if the values of r, both the values of r are equal, then line intersect the sphere in only one point, that is, in that case the line is tangent to the sphere. So we have here r is equal to 1 and 1, both the values of r are equal. The quadratic equation in r has two equal roots, and therefore the line and sphere have only one point in common, or the line intersect the sphere in only one point. This means the line touches the sphere, or we say that the line is tangent to the sphere. Okay, then we have to find the point of contact. There is only one point of contact or point of intersection of line and sphere in this case. So substitute r as 1 in this general coordinate of the point on the line. We have 4, 1 minus 7 means minus 3, 4 into 1 minus 7, minus 5 into 1 minus 5, substitute r as 1, plus 6 comma 5 into 1 minus 4, that is equal to, we have the answer minus 3 plus 1 and plus 1. So this is the point of contact. So in order to show the line is tangent to the sphere, and in order, if we have to find the length of the intercept made by the line, procedures are same. So another problems of this type, and prove that the straight line this touches the sphere x square plus y square plus z square is equal to 0. That is why to show this line is tangent to the sphere. Also find the point of contact. So procedure is said, let the equation x plus, this is the equation of line, is equal to say r or lambda. Say it's equal to r, and then find the value of x, y and z. These are the values of x, y and z. If this line intersect the sphere is equal to 9, it is not 0, it is 9. So already this problem is solved. So we have if the line if the these are the coordinate of the general point, then if the this point lies on the sphere, then we have this, and we have the value of r or lambda, both are 0 and 0, and therefore the quadratic equation in lambda has two equal roots. Therefore the line and sphere have only one point in common, and this means the line touches the sphere. Then put lambda is equal to 0, we get the point of contact from this xy value of xyz as a minus 1, 2, 2. So next problem is what? Find the length of the intercept cut up by the line x plus 2 by 1. Here is the equation again in symmetrical form. X plus 1, x plus 2 by 1. The equation is in this form. Y plus 3 by 1 is equal to z plus 5 by 1. On the sphere, x square plus y square plus z square minus 6x plus 5z plus 11 is equal to 0. That is again this line is given, the equation of line given in symmetrical form, and this line intersect the sphere in 2 points, and we have to find the length of that intercept. So first we'll find the point of intersection of line and sphere. So the procedure is said, that is the equation of line is this: x plus 2 by 1, y plus 3 by 1, and z plus 5 by 1 is equal to say r. Then any point or the coordinate of general point on this line are what? That is, find the value of x as is equal to r. X plus 2 by 1 is equal to r gives x is equal to minus 2 plus r, or r minus 2. Y is r minus 3, and z is r minus 5, or 5 minus 5 plus r. And then if this point lies on the sphere, that is where to find the point of intersection of line and sphere. So this is the point on the line, and if this point lies on the sphere, this sphere, what we have, the this point satisfies the equation of sphere. That is, substitute x as minus 2 plus r, y as minus 3 plus r, z as minus 5 plus r. So we have this equation. Then simplify this, square this bracket, the square of this bracket. So square of this bracket is what? 4 minus 4r plus r square. Again, the square of this bracket is what? 9 plus 9, then minus 6r plus r square. Square of this bracket is what? Plus 25 minus 10r plus r square. Then multiply by minus 6, multiply by plus 5, and add and subtract of the terms of r square, r and constant term. We have this. Dividing by 3, we have this equation: r square minus 7r plus 12 is equal to 0. And if we factorize this equation, then we have r minus 3 in another bracket, r minus 4. So multiplication of minus 3 and minus 4 is plus 12, and addition of minus 3 and minus 4 is minus 7. So r, the values of r are 3 and 4. We have the two values of r. So the line intersect the sphere in 2 points now. And so how we can find the point of intersection? First substitute r is equal to 3 in this formula. That is the point on the line. So if you substitute r is equal to 3, then minus 2 plus 3r is 1, minus 3r plus 2 is 0, plus minus 3 plus 3, and minus 5 minus plus 3 becomes minus 2 as first point of intersection. Then substitute r as 4 gives the point, suppose q, and substitute r as 4. So minus 2 plus 4 is plus 2, minus 3 plus 4 is 1, and minus 5 plus 4 is minus 1. So these are the 2 points of intersection of line and sphere. Now the distance between PQ, by using distance formula, root 1 minus 2 bracket square, 0 minus 1 bracket square, and minus 2 plus 1, minus 2 minus minus become plus 1 bracket square. So this is minus 1 square, minus 1 square, minus 1 square, that is 1 plus 1 plus 1, that is root 3. And so this is the final answer, that is the length of the intercept cut off by the line on the sphere, or the length of the intercept made by the line with the sphere. So these are important problems, that the intersection of line and sphere, that is the line intersect the sphere. These are some problems for homework. Find the length of the intercept made by the line with this, and find the coordinate of the point where the line intersect the sphere. So this is the problem for homework, that find the coordinate of the point where the line intersect the sphere. So this line intersect the sphere in 2 points. So this equation of line is in the symmetrical form. So how we can write this? equation in symmetrical form, it is x minus 0 by 2. It is y minus 0 by 2, and this is what? Z minus 0 by 1. So now we have, it is compared with is equal to r, and find the value of x by z and follow the procedure. We have the two values of r, and from that we have the 2 point of intersection of line and sphere. Same problem is here. Prove that the straight line this touches the sphere this, that is this line intersect the sphere in only one point. Also find the point of contact. So solve all these problems of assignment. So this is the answer of the previous homework problem, assignment problem, that show that the two spheres touch each other and find their point of contact. So we have to show these two spheres touches each other. So when we said the two spheres touch each other, if the point of contact, their point of contact is unique, like this. If this happen, suppose these are the two spheres, number one and number two, and find their centers and radius. Suppose the center of first sphere is C1 and radius is R1. So we have the value of C1 and R1 as 130 C1 and R1 is 5. So how we can find the coordinate of center and radius? That is, compare these equations with the equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Find the values of u, v, w, and then write the center and radius of both the spheres. That is, these are the C1 and C2 are the centers, and R1 and R2 are the radius of the two spheres. Then find the distance between C1 and C2 by using distance formula. So it is what? Root 1 minus 1 bracket square, then 3 minus minus plus 13 by 5 bracket square, and then 0 minus minus plus 21 by 5 bracket square, and then we have this answer 7 as the distance between C1 and C2. And what is R1 plus R2? R1 plus R2 is again 7, and so we say C1 C2, that is the distance between C1 and C2 is equal to R1 plus R2, and therefore we say two spheres touches externally, that is the two spheres touch each other. Okay, and then also we have to find the point of contact, then use the section formula. Suppose the point of contact is P has the coordinate, suppose x, y, z, then this point P divides this C1 C2 internally in the ratio 5:2, 5:2, and therefore by section formula x is equal to 5 into 1 plus 2 into 1 divided by 5 plus 2. Section formula 5 into 1 plus 2 into 1 divided by 5 plus 7, that is 1. Then y is what? What is the value of y? Y is 5 into minus 13 by 5 plus 2 into 3 divided by 5 plus 2. Here observe this 5 into minus 13 by 5 plus 2 into 3 divided by 5 plus. That is again minus 1 answer. We have the minus 1 answer. And what is z? Z is 5 into minus 21 by 5 plus 2 into 0 divided by 5 plus 2, and its calculation is minus 3, and therefore the point of contact of these two sphere is what? 1 minus 1 3. So 1 minus 1 minus 3. So this is the answer of previous problem. So solve the problems of the type that show that the line is tangent to the sphere. So we'll see the remaining problem in the next lecture.